Hello everybody, welcome to this vlog. My name is Satya. In the past 6 to 7 videos I have been doing uh, a vlog on routing protocols. So as part of routing protocols we discussed about OSPF, BGP, ISIS, why BGP is used in the ISP network between autonomous systems or between two ISP networks, why ISIS is preferred IGP protocol compared to uh, OSPF, and then why IBGP needs IGP protocols like OSPF and ISIS to function. But the basic thing is we have been telling about these protocols, how it is useful, how one is better than other. So different ways we explain the routing protocols. But we never discussed about the basic thing, which is IP address routing, right? So as part of this vlog I would like to discuss about the basics of routing protocols, basics of routing basically I should say, instead of routing protocols. So let's see, as you see on the shared PowerPoint presentation, I've defined host 1, host 2, router 1, router 2. So host 1 is having an IP address which is highlighted here, 192.168.0.2. Router 1 is having an IP address 192.168.0.1. Host 2 is having an IP address 192.168.1.2, and router 2 is having an IP address 192.168.1.1. Now let's say, and I have described in previous vlogs what is an IP address. So if you have doubt in that, then I would say that defining IP address as part of this vlog would not be sufficient, right? Because I have already described about IP address basics. If you want, or I will put the video where I explain IP address separately in a different vlog. You can go through this and then attend this vlog, or go through this vlog to get an idea what I'm talking about. So here, so if host 1 wants to communicate with host 2, right, then the first thing is there is no direct connection, right? They are sitting in a two different subnets. Subnetting is also explained in previous vlogs. I'll put a video to that, and I will you guys can go through it to understand what the subnet is. So the subnet is basically defined by the highlighted numericals. So host 1 is in the same subnet as router 1 because the third tuple, the third byte is 0, and the third byte in host 1 is also 0. So it should be similar, right? Usually the subnets are defined as 255, 255, 255.0. It is not necessarily it should be same, right? For example, if the subnet is 255, 255, 254.0, then there are 255 IP addresses, that is 0 to 255 plus 0 to 255. So totally it would be 512 IP addresses in that subnet. But here in this example I am considering a subnet as 255, 255, 255.0. That means to say it is only one 255 tuple. So only 256 IP addresses are part of each subnet, right? So I have given, usually everybody defines the router IP address as 192.168.0.1. That is the first IP address in the subnet. And the host IP addresses are like 192.168.0.2, 0.3, 0.4, like that till 0.254. Now, let's suppose what happens when a router is started, router 1. Or for example, router 1 is already configured with an IP address as 192.168.0.1. When host 1 starts, that is this PC, when it starts, if it is configured for dynamic host configuration protocol, which is to get an IP address automatically, then you will send a DHCP discover to a broadcast IP address. And what is broadcast IP address? Broadcast IP address is 255.255.255. Right? All the bytes are 255. Once a DHCP discover is sent to the broadcast, whichever nodes, hosts and router, they receive the DHCP discover in this subnet, right? The highlighted ones. In this subnet, you will receive the DHCP discover. Router 1 will say, yes, I am having a DHCP server application. Let me give an offer, DHCP offer to host 1. Host 1 gets an IP address in DHCP offer with the gateway IP address as 192.168.0.1. Host 1 configures 192.168.0.2 IP address to its interface on which it asks for DHCP address, and configures the next op router as 192.168.0.1. So that's how it's being configured, right? It's only not DHCP discover, DHCP offer. Once a DHCP offer is there, host 1 makes a formal request, which is DHCP request to router 1. Finally, router 1 hacks that request. So the complete handshake is 4 messages: discover, offer, request and hack. So it's in short form called as DORA, right? That handshake is called as DORA, famously called as DORA. So now host 1 has an IP address. Its source IP address as 192.168.0.2, and router 1 and also the gateway IP address as 192.168.0.1. Gateway IP and router IP are both same, right? I will use both the terms, so don't get confused, both are same. Now let's suppose host 1 192.168.0.2 wants to send a ping. Ping is an ICMP message. It is Internet Control Message Protocol. It is used to understand, that protocol suite is used to have a connectivity check. One of the features of ICMP protocol is connectivity check. So host 1 sends a ping request to router 1. Then we got an gateway IP address. As I told in my previous vlogs, the communication in the subnet on the link happens through MAC addresses. So we have a TCP IP protocol suite. In that, MAC layer will have MAC addresses, IP layer will have IP addresses which are virtual. MAC addresses are hardware addresses. So first host 1 will send an R packet asking for who has 192.168.0.1. Tell me its MAC address. Router 1 is the uplink router, is connected. He will say, I have the IP address 192.168.0.1. So this is my MAC address. Once host 1 gets at that MAC address, it populates its ARP cache or neighbor cache, we can say, saying that to reach for the next next packet sent to 192.168.0.1, I will use the ARP cache populated MAC address. He will send an ICMP packet to router 1 and he will respond with the ICMP reply, ping reply, saying I am reachable. Right? So that's how the communication happens between router 1 and host 1. Now let's suppose we want to send a packet from host 1 to router 2 address 192.168.1.1. Now, as I told you in the beginning of the vlog or the class, that I am considering subnetting as 255.255.255.0, 255.255.255.0, that's for correction. So each third byte should be same. So 0 is not same as 1. So host 1 considers 192.168.1.1 as not in the same subnet. Right? So now to send a ping packet from 192.168.0.2 to 192.168.1.1, it has to go through router 1 address 192.168.0.1. Right? If for example by mistake you put in ARP cache saying that 192.168.1.1 is having this MAC address manually, then you will not be able to reach router 2. Even though MAC address is there, that MAC address is not there in this subnet, so that communication will fail. So don't play with ARP cache if you are not sure what you are trying to do. Right? So in this dynamic host configuration protocol, provided a gateway IP address, ARP resolved the gateway IP address to MAC address. So for the unknown IP address within this host 1, because 192.168.1.0 subnet is not understood to host 1, so he will not send the packet. So what we need to do, we need to define, let me tell here, we need to define default route in host 1. That default route for IPv4, again I have described what is IPv4 and IPv6 in the vlogs. Please go through all the vlogs in my channel, which is called as Chow Chow Bath 7132. This channel has all the vlogs. By this time I have covered all the basics. So default route is defined as 0.0.0.0/0. Right? This should point to 192.168.0.1 on host 1. Okay, so this route should be there in host 1. If this route is not there, then you have to explicitly define a static route saying 192.168.1.0/24. you have to reach 192.168.0.1 gateway on host 1. Now you might ask, oh, no, I don't want to define this 0.0.0. I will define this. Then you have to define for each packet sent to a different subnet, then you have to define that subnet like this. Scaling is very difficult, right? Here you cannot scale, so that's why in the TCP/IP protocol stack, this definition means a default route. If a route is not there in the routing table for that particular subnet, then check if there is a default route and send the packet to default route mapped gateway. Right? So now whether you have this route or this route. Host 1 will send the packet, ping packet, with to the first gateway IP address, which is called 192.168.0.1. right? That MAC address we already resolved by sending a ping to it. So neighbor cache or ARP cache will have that MAC address. So once that packet is sent, ICMP packet is sent to this gateway IP address. Once it is received here, it will see whether there is a route existing in this router, to router 2, which is 192.168.1.1. right? Here we defined, but there has to be a route here also, saying that to reach 192.168.1.0 we have to go through on this interface, right? So you may ask me, do we need to define it? No. Host 1 has one interface, physical interface, which is highlighted here. Router 1 has, from here, this interface and this interface. So on this interface we need to define a separate IP address. Let's say it is 192.168.1.3. okay, so this interface is having one IP address called as 192.168.1.3, and this address is 192.168.1.1. now here automatically a route will be created saying to reach 192.168.1.0/24 use this interface. A dynamic routing entry will be created because we have sent an IP address 1.3 to this interface. So that will be /24 means it will create a dynamic routing entry here. So once the dynamic routing entry is created, this router 1 knows that once it received the ping packet from 192.168.0.2 source address, it reached here. Now he knows to reach 1.1 he has to go through on this interface, right? So what he will do is he will send a ARP request to 192.168.1.1 on this interface. Once the ARP response is received, he puts that MAC address. Source address is not changed. Destination address is 192.168.0.2 source address, and the destination address is 192.168.1.1, and he will send for route the packet to this interface. Here that packet belongs to router 2. He checks the interface routing entry, and the interface 192.168.1.1 is its IP address. Now ping will still fail because here we did not say how to reach 192.168.0.0/24 subnet. So here there has to be another route on routing. This is on router 1. Then 192.168.0.0/24 should be defined on router 2. Okay, once this route is defined here on router 2, he knows to reach 192.168.0.0/24 he has to go through a next hop IP address 192.168.1.3, right? To reach here 1.3 is on this interface, so router 2 will define this IP address. Then you will send again ICMP reply message to 1.3. 1.3 is the destination, so he has to, the destination IP address is 192.168.0.2 in the ICMP reply. Source address is 192.168.1.1, but the MAC address, destination MAC address will be 1.3. So it comes here, he sees that the destination IP address is 192.168.0.2. he knows that this is the interface on which he can reach, so he'll route the ICMP reply here. So this is how a packet transmission happens from host 1 to route 2, right? So to summarize, for this particular routing entry or routing scenario, host 1 will have 192.168.0.2 and router 1 will have this interface, highlighted interface, in 192.168.0.0 subnet, right? Now 192.168.0.2, when he sends a ping message to 192.168.1.1, which is router 2 on this which is reachable here, router 1 should, first of all, to host 1 to send a packet to 192.168.1.1, he needs to have a default route or a specific route to that subnet on host 1. Then what is required on router 1 to route that packet to router 2? He needs to have a IP address defined for this interface, highlighted interface, like 192.168.1.3/24 on router 1. He knows. So then router 1 knows this interface is the destination interface for routing a packet to 1.1. Once it receives here, router 2 should know how to reach 192.168.0.0/24 subnet. There we need to have a static route saying 192.168.0.0/24 on router 2, and that should be mapped to next hop address 192.168.1.3. So friends, this is what I want to do. Here I have intentionally made a mistake. Host 2 is in the same subnet as this interface, right? So when you do this, it will clearly say on the router 2, you can't have same IP address or same subnet on two different interfaces. So I will correct this. I intentionally made it, so I will correct this in the next class. So we will continue the basics in the next class. So in this vlog or in this class, we discussed about how host 1 configures an IP address and how host 1 reaches router 1 and how host 1 reaches router 2 IP address, right? So in the next vlog, I'll discuss about communication from host 1 through router 1, router 2, and it will reach till host 2. Okay, so thank you for your time. I hope this vlog was clear or it's well understood. So if you like the vlog, do put a message or comment, and if you like the vlog, also do click the like button and subscribe, most importantly. Thank you. Bye.